Hello everyone, welcome back to this channel. Sorry for uploading video late as I was busy with some works. Anyway, let me tell you the whole setup. Okay, first we started this course Intro to Deep Learning. This is in Kaggle Learn. You can click on Learn, then you will be able to get many courses. From there, we selected this one Intro to Deep Learning. Okay, in our last class, we studied about this one a single neuron. First, we understood the tutorial and then we did the exercise. Okay, so today we are going to do the deep neural network. First, I will tell you the concept, whatever it's written here, then we will do the exercise. Okay. In our last class, we studied about a single neuron, and now we will understand how to create a deep neural network. Okay. So we are going to see how we can build neural networks capable of learning the complex kind of relationships deep neural nets are famous for. Why deep neural networks are famous? Because they can learn the complex relationships. Okay. For that, we can use different layers. In our last class, we studied how to create a single layer neuron. But now we can create different layers of neuron. Okay. The key idea here is modularity, building up a complex network from simpler functional unit. Every unit is simple, but combining them will create a complex network, which will capture the complex relationships from the data. Simple thing. Okay. Now we will see how to combine and modify these single units. Layers. You know what is layers? Layers means say here this is the layer. This is a layer. This is a layer. Input layer, dense layer, output layers. Okay. So typically organize their neurons into layers. When we collect together linear units having a common set of inputs, we get a dense layer. This one is a dense layer because here we are getting common set of inputs. See, this single neuron is getting from x0, x1, 1. These are inputs. Same, this layer also, sorry, this neuron also getting all these inputs x0, x1, 1. So combining all these layers we can call dense layer. It is also getting same inputs, it is also getting same inputs. So collecting together all the linear units having common set of inputs creates a dense layer. Clear? So here this is the input layer, this is a dense layer and this is an output layer. Your outputs sometimes may be one output or sometimes it may be more than output depending on which kind of prediction you are doing. If you are doing classification, like you want to know whether the picture is of a dog or a cat. So that may be two types of outputs. It may be dog, it may be cat, right? It may be 0, it may be 1. Okay. Or suppose if you want a single number, like the price of a flat. So there you will get a single value. There you will have one output. So depending on the types of prediction, the output layer may have single output or it may have multiple output. Okay. Now see, you could think of each layer in a neural network as performing some kind of relatively simple transformation. Through a deep stack of layers, a neural network can transform its input in more and more complex way. In a well-trained neural network, each layer is a transformation getting us a little bit closer to a solution. This simply means that when we create different layers, each layer is capturing a bit from the input. The next layer is capturing some more features. The next layer is capturing some more hidden insights. Okay, so each layer is giving some more information which is bringing us to the solution. Okay, now let's read the activation function. Activation function simply means that it can capture the non-linearity from the dataset. Two dense layers with nothing in between are no better than a single layer by itself. Dense layers by themselves can never move us out of the world of lines and planes. It simply means that if you create only dense layer, then it will always capture the linearity in the relationship. But what if the dataset has some non-linearity? For that, we need activation functions. This is an important interview questions. They may ask you that why do we need the activation function? Then you have to say if your dataset has some non-linearity, then you have to use the activation function. Otherwise, the non-linearity from the dataset cannot be captured from the dense layer. Clear? So you can say that without activation function, neural networks can only learn linear relations. Okay, if you don't know about activation function, then you can read this blog. It's written by me. Here I have explained what is sigmoid, what is tanh, what is ReLU, and what is softmax. This will give you basic idea about what types of activation functions we can use. Okay, this is very important for your interview part. Anyway, let's come back to our main focus. Okay, now see, an activation function is simply some function which apply for each of the layers output. The most common is rectifier function. What happens, whatever your output is from the dense layer, whatever it has captured, after that we apply an equation on that output, right? Like it may be ReLU, it may be sigmoid, it may be tanh. All these are activation functions. Even in ReLU also there are different types of activation functions like leaky ReLU, parametric ReLU, LU. Okay, so these are nothing but some equations. Why these equations are applied? Because sometimes your output may be huge, maybe big, or maybe very small. So what you have to do, you have to just apply the equation, that means the activation function, and bring the output into a range. Then your non-linearity will be captured easily. Simple. Anyway, the rectifier function has a graph, that's the line with the negative part rectified to 0. Applying the function to the outputs of a neuron will put a blend in the data, moving us away from simple lines. Okay. So when we attach the rectifier to a linear unit, we get a ReLU function. For the reason it's common to call the ReLU function. Applying a ReLU activation to a linear means output becomes, this is the equation, max of 0 comma wx plus b. You simply can say that whatever is the negative part will become 0, because you have to take the maximum of either 0 or the value. If the value is negative, then you are simply ignoring, you are taking the max value, which is the max value, that is 0. That means the negative part will become 0. Okay, so the diagram is like this. This is the graph of ReLU. This is how it works. So whatever your output is, if there is anything negative, if the output is in a big range, then the negative part will be 0 and the positive part will be captured. So it will just give you a bend in the data. Okay, this is W. W is, what is W? W is the weight. X is the input. B is the bias. So output will be Wx plus B. If it is negative, then you will take 0, because maximum value is 0 here among the 0 and the negative one. Okay, so you are simply ignoring the negatives. I think you have to study activation functions in details if you don't know. Okay, we are just revising the things here. Okay, now the next is stacking dense layer. You understand what is nonlinearity. Now what happens, you are taking many neurons. So here also you are taking dense layer, you are putting activation functions, again you are sending it to next layer, you are putting some dense layer, you are putting some activation functions, and combining all of this you are getting the output. So this neuron is capturing some data, some value, this neuron is capturing some value from the data set, this one is capturing some value on the data set. By putting activation functions, you are bringing them into a range. Again, you are applying dense layer. Again, it is capturing some value, some formats. And again, you are putting some activation functions. And finally, you are getting the output. So, this is stacked dense layer, making a fully connected network. Fine. The layers before the output layers are sometimes called the hidden layers, because this one you can see, but you cannot see what is happening here. I hope you know that if interviewer asks you a question that what is the main problem with deep learning, then you can say that we don't know what is happening inside. Sometimes the output may be odd or may give something which is not so usual. So if your the client questions that why the output is like that, then you will not be able to answer why your model is behaving like that. You don't know what is happening inside. In machine learning, you know what is happening. That is transparent. You can see that why your model is behaving like that. You can explain. Okay, but in deep learning, these layers are not explainable. You cannot explain what is happening inside. So that's a kind of a problem with deep learning. Anyway, that's not our topic. We will only know that why these are called hidden layers, because you cannot see them. You can see the output only. Okay. Now notice that the final layer is a linear unit. That means no activation function. Here they have not applied any activation function. You can, but here they have not applied. That means the network is appropriate for a regression task where we are trying to predict some arbitrary number value. For classification, classification means you have to give a boundary. You have to say either it is 0 or it is a 1. So there always you will need an activation function. But if you are working with regression, means it will give you a value only. As I said, it will give you the price of a flat. It's generating a number, a numerical value. Then you may avoid activation function. So it depends like on which you are working. Okay. And even which activation function is better, whether ReLU, whether 10H, whether sigmoid. You can experiment with all these things while you will doing these things. You are creating the layers. You can use different kind of activation functions to check which one is giving you the best output. Okay. Let's do this one. So this is a package where we have to import the Keras, we have to import layers. Okay, this will help us to create the dense layer. So we are just creating the model. We are just creating this layer. So we will tell how many layers will be, sorry, how many layers will be there. One, two here, like two layers. So you may have three layers, four layers. How many units will be in the layers? So all these things are created here. So first we are creating these are the hidden ReLU layers. Layers.dense units equal to 4 activation ReLU input step 2. Input step, you know, input step is simple. That means your data set has two inputs, one output. So that's why input step is 2. Okay. Activation function, they have used ReLU. ReLU actually performs better in most of the cases. That's why it's so famous. Okay. And now the number of units. In the first layer, you are giving 4 units. Like see here, it is given 5, but if you want, you just create 4 units. Okay. In the second layer, you give 3 units. Means in this layer, uh, sorry, here also it is 4 units only. One is the bias. Okay. So here it is 4 units and here it is 3 units. So units 4 activation ReLU input step is 2. Second layer, unit 3 activation ReLU. Okay, so you have created two hidden layers. Now you have to create the output. Okay, so the output is unit equal to 1 because you want only one output. Fine, and you have not used any activation function. If you have used, then you have to write comma activation equal to ReLU. Clear? Now be sure to pass all the layers in a list. All the layers must be in a list. See here, the list has been started from here. Okay, and inside you can create more layers. If you want, you can create some other layers with different kind of inputs using different kind of ReLU functions. Sorry, different kind of activation functions, and you can experiment with them like how your model is showing the output. Okay. Anyway, this is the simple theory part. Now let's do the practice it. You try to do it by yourself. If you do it by yourself, then it will be very clear to you that what's happening inside. Anyway, let's read. In the tutorial, we saw how to build by stacking layer inside a sequential model. By adding an activation function after the hidden layers, we gave the network the ability to learn more complex relationship and non-linearity. Let me run first this one. It has imported TensorFlow. TF is the alias matplotlib for what? For plotting. These are just plotting the figures, giving figure, label size, title size. Okay. Anyway, let's do it here. Tell me what is happening here. Simple things, just reading the data set. They have a data set, DL course data, a CSV file. It is reading and then the head function will show you first 5 rows. Okay. The head part of the data set. Uh, Let me run this one. What is happening? Oh, still running. Anyway. Next one is this is our task. Okay, it is done. See here. This is a concrete. That means cement. See, cement, blast furnace slag, fly ash, water. I don't know what are this. These are some ingredients in the cement. Okay, and this is the compressive strength. This is our output, and all these things are input. So you can see 1, 2, 3, 4, 5, 6, 7, 7, 8. So 8 input and 1 output. Okay. They have asked for input step. This one we did in our last class also. You can write 8 because you can see that it is 8. So if you run this, it will show you it's okay. Okay. So these are ingredients in a cement and what is the strength of the cement. Okay. If you want, you can simply just remove this and then run it. You will be able to see the solution and the hint. Okay. Anyway, next one is define a model with hidden layers. Now create a model with three hidden layers, each having 512 units and a ReLU function. Be sure to include an output layer of 1 unit and no activation function. Let's create the model. So first we have to write Keras dot sequential. Now within the list you have to create the layers. Okay, first three hidden layers. Okay, so Keras dot sequential layers dot dense and having 512 units. So I will write units equals to 512. Activation is ReLU. So activation equals to ReLU and anything else you have to just mention the input shape. So input shape equals to input shape. Because here we have already set input shape equals to 8. So it will take this parameter value directly. Fine. Now create the next layer. Next layer, layers dot dense and units equal to 512. Just let me give a, yeah, fine. Comma, activation equal to same ReLU. So two layers are created, but they have told three layers. So what I have to do, one more layers. So layers dot dense, you can copy also. It is better in fact. Units 512 and activation equals to ReLU. Okay, so done. Now next we have to create the output layer. So we can simply write layers dot dense units equal to 1. Okay. And in the output layer, 1 unit, no activation. So I will not write any activation. Okay. And input save as an argument to the first layer. We have done this. Now let's run it. See. Okay. Activation. I'm so sorry. Fine. You can first, if you can't, then first click the hint, then see the solution. Okay. Now activation layers. Let's explore the activation function sum. The usual way of attaching an activation function to a dense layer is to include it as part of the definition with the activation argument. Sometimes you will want to put some other layer between the dense layer. That simply means that here what we are doing, we are creating the dense layer. With that, we are also giving the activation layers. But see, there may be some scenario where you have the dense layer, you create one more dense layer, then you put the activation layer. You understand my point? In the dense layer, I don't want to put the activation on that. I want to create one more dense layer. Then maybe at the end, I want to put the activation layers. Okay, so for that, what you can do? For that, they are asking you to create separation. Separate for dense layer, separate for activation layers. Okay. See here, layers.dense, you need 8. Then you create activation layers. Layers.activation ReLU. So that both of them doesn't get combined. Okay. So let's change it. So, okay. So let's rewrite this. So layer.dense 32 activation ReLU. We have to delete this. In the first layer, there will be only inputs and the input set. Fine. In the second layer, it will be layers dot activation. Because we have created the dense layer and now we are creating the activation layer. We are not combining them. Simple. So here you have to delete all these things. Just write ReLU. Fine. In the next, you will have output. Okay. Now let's run it. Your model doesn't have the correct kinds of layer. You should have 5 layers with classes. Oh, you have to create 5 layers. Sorry, they have said it in the they have not mentioned. Anyway, they are creating 5 layers. So let's do what you have to do. Just copy paste. After you have put the dense layer, you put again dense layer. Okay. Next, I'm creating another layer of activation function. Okay. Now dense activation, dense activation, dense, dense activation, activation, dense activation, dense. That means done. Okay. Now let's run it. Okay. So just simple thing, we are creating separate layers. For dense layers, it's separate. For activation layers, it's separate. Okay. You can check from here. Now next, optional alternatives to ReLU. We have already discussed this, that this is a whole family of variants ReLU. ReLU also have different kinds of variants, LU, CELU, Swiss, among all of which you can use in Keras. Sometimes one activation will perform better than another. So you could consider experimenting with activations as you develop a model. ReLU tends to do well. So it's a good one to start with. Let's look at the graph sum of this. See, choose the activation from ReLU or any other name and see how the graph looks. This is the ReLU activation functions. Let me run this one. Okay, ReLU looks like this because you are making it zero for any negative value of input. If it is -1, -2, -3, it is negative. Whenever it's negative, ReLU function, the ReLU equation will make it a zero. Okay, so this is what ReLU looks like. If you just delete it and create LU, see, it looks different. What for CELU? So you just do it by yourself. You will be able to see the graph. See, this is different. Okay, here it is not creating zero. For negative also, the output has some negative values. Then in zeroth value, it will become zero. After that, the positivity is captured. Okay, so in our next class, we will study the next part. Okay, till then, bye. Happy learning.